In this course of architectural presentation techniques, we are going to talk about descriptive geometry. Throughout the course, I will be using this book as our main reference. He was written by one of our former professors. He's retired now, but he is the Professor Ali Düzgün. He is the one who gave this course through many years in our university. Let's start with the definition of descriptive geometry. In Turkish, we call it tasarı geometry. We can say that a descriptive geometry can be defined as a field of study for expressing 1, 2, or 3-dimensional objects on a 2-dimensional picture plane. Also, this study examines the objects and their relations between them in a systematic way. Here we need to talk about the notion of projection. In Turkish, we call it izdüşüm. Projection is the art of creating an image, we can say a mark, of an object on a planar surface by directing a ray. This ray can be a perpendicular ray or it can be inclined over the object so that we will get an image of that object on a planar surface, on a projection surface. Here, there is this very nice video. We can watch it together.
Hello. Today, I will take you through theory of projections. The projection is a process of creating an image of the object on the paper as it appears when observed in a particular direction. The shape of an object is represented as a combination of elements, points, lines, and planes. Using these elements as tools of drawing, we can project an outline of the object on the paper. We will use orthographic projection, where lines of sight are parallel to each other. These lines emerge from the corner points of the object and strike the projection plane. The image formed on the projection plane is known as the projection. The lines of sight are also known as the projectors. The size and the shape of the projection depends on the angle at which the object is being viewed and the distance between the object and the viewer. The projectors are perpendicular to the plane of projection. This type is known as orthogonal projection, which is prominently used in engineering drawing as they show true size proportions and shape of the objects.
As the guy in the video said, we are going to use the orthographic projection. We can say parallel projection, or in Turkish dik paralel izdüşüm for this. If we use a ray that is perpendicular to the projection plane, we can get an orthographic projection. Here we have the actual object. Let's say that that's point A, and when we cast a ray that is perpendicular to this surface, which we call projection plane. This is called projection plane. We can get an image, a mark, or we can say a projection of this actual point A here on this surface. We can think like that. When we look from the above, we cannot see, if we are just looking right above, directly above, we will not be able to notice that there is a level difference between the point A and the projection plane, and it appears that it seems like this point is actually on this plane. We think like that. So this is what we are going to do here. And as you see, to express certain objects in technical drawings, especially in technical drawings, we mostly prefer orthographic projection in fields like architecture or mechanical engineering. This is a drawing made by mechanical engineers. Here we see a piece. a pipe probably. And again, we noticed that they used orthographic projection. Why is that? We can say that, as the guy in the video told us, we can say that it's one of the easiest ways, easiest methods to get a true size of of an object. We need the true sizes, true dimensions. So we use this method to draw. What happens if you don't prefer orthographic projection? Or here, there is another example. This type of projection is particularly important if we are looking for the production of these objects. If we want to produce them, we need to draw them, get the image in their true sizes. And the other one is the one that we witnessed in the last two videos is called central projection, or we can say konik izdüşüm in Turkish. Here we have again the rays, but they are not perpendicular to the projection plane, and there are multiple rays. They originate from a certain central point, so that we will have a central projection on the projection plane. Here we see the actual object, and that's the source of the rays, and we cast rays, and we get the image. If the object is positioned, between the central point and the projection plane, the projection will be bigger than the object. If the plane is positioned between the object itself and the central point, then the image, the projection, will appear smaller than the object itself. That's the main reason why we prefer orthographic projection in technical drawings. Here, we need to talk about the projection planes. In Turkish, we can say izdüşüm düzlemleri for this. We use three main projection planes in order to determine the exact position of an object in space. Using only one projection plane, just this one, cannot be enough. So in addition to the horizontal projection plane, which we symbolize with capital H, we can use a vertical, again, we can symbolize it with capital V, and a profile that is being symbolized by capital P. Projection planes, they are all positioned perpendicular to each other. So we create a kind of a cube, and we are using its inner corner, inner environment. Here we can say level. That is the perpendicular length between the object and the horizontal projection plane, the H. This is called level, or kot in Turkish, level or kot in Turkish. Here we see interval, or we can say depth. In Turkish, it's called aralık. That is the perpendicular length between V and the object itself. Distance, the last one, is the perpendicular length between the object and the P, profile projection plane. By using these three distances, these three lengths, we can create the projection of an actual object by using this system. Once we created the projection of on H, V, and P, we can rotate H here, this horizontal one. We can rotate it around the HV intersection, around this line here, for 90 degrees. And similarly, we can rotate the P around VP intersection, here, this vertical line, around this vertical line for 90 degrees. And they will coincide and form one frontal plane. We will have a representation system. This is called a pure of Monge, or orthographic drawing of Monge. Monge is the surname of a scientist, a mathematician. He was French. He lived between 1746 and 1818. He invented this method. He is the founder of descriptive geometry. So we are using his name as a pure of Monge. Yes, we can start with projection of points.